Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and in this video we are going to solve another gate question. So this gate question was asked in the year 2002 for 2 marks. So let's read this question. So the question goes like this: draw the process state transition diagram of an operating system in which the first condition is that each process is in one of the 5 states, that is created, ready, running, blocked, that is sleep or wait, or terminated. And the second condition for this diagram is that only non-preemptive scheduling is used by the operating system. And finally, they have asked to label the transitions appropriately. So basically, this is a question related to the process state transition diagram, right? And this is a subjective question, that is in the year 2002. In that year, before the format was different, so now only objective questions are asked, that is multiple choice questions. But back then, subjective questions like this were also asked, that is draw a diagram or write a paragraph on some question. So nonetheless, we'll solve this question. So let's list down the two requirements that we have. So the key points that we have to focus in this question is that each process is in one of the 5 states, that is created, ready, running, blocked, or terminated. So this is a fairly simple requirement. We have already talked about the process state transition diagram in the earlier video, where we talked about the life cycle of a process. So these 5 states are already there. This condition is kind of trivially fulfilled. We don't have to do much. Then the second condition is that only non-preemptive scheduling is used by the operating system. This will have to incorporate into the diagram. So let's see how we can do this. So here is the diagram that we have already studied. I have taken the diagram from the process state diagram that we talked about when we studied the life cycle of a process. So let me quickly recall the different states that are there in this diagram, and then we will modify the states accordingly. So the first state is the new state. Whenever a process is created, then it goes into the new state. So in this question, they have asked that each process should be in one of the 5 states, that is created, ready, running, blocked, or terminated. So the new state is same as created. Okay. Then after from the new state, the process eventually transitions into the ready state. So in the ready state, there are a lot of processes, and all of them are waiting for the control of the CPU to be assigned to them. So basically, the number of processes in the system will be way more than the number of CPUs, right? And only a few of the processes will have the control of the CPU. Rest of them will be in the ready state. They will be waiting for the control of the CPU. Then from the ready state, the process goes into the running state when it is scheduled. That is, whenever the control of the CPU is allocated to the process, then the process goes from ready to the running state, where it executes the instructions on the CPU. Now, from the running state, there are 3 possibilities. The first one, the simple possibility, is that after executing its instructions, the process transitions from the running to the terminated state. That is, it finishes its execution. Then there are other 2 possibilities. The other one is that the process can go from running to ready state. This will happen when the process is descheduled. That is, the control of the CPU is taken away from the process. So each process will be allowed to run for a brief amount of time. It will not be allowed to use the CPU for an indefinite time. Okay. So what happens is that the operating system, whenever it feels that the current process has been executing for a long time, it takes or snatches away the control of the CPU forcefully from the running process. And when that happens, that running process goes into the ready state. Okay. Then the last possibility for a running process is that it can go into the waiting state. So there are several occasions during which a running process has to wait for a certain event to occur. Okay. So whenever a process has to wait for an event to occur, it goes into the waiting state. In this state, basically, it cannot execute instructions even if you allocate the CPU to it, because it is waiting for a certain event. So examples of these events are like it is waiting for a IO operation to complete. Let's say it is waiting for some input. Unless the input data arrives, it cannot execute. Or it could be requesting for a resource, and until that resource is allocated to the process, it cannot continue its execution. So this is the waiting state where the process is kind of blocked. So in the question, they have asked to name the waiting state as block state. So the block state and the waiting state are the same. And finally, whenever that event happens for which the particular process is waiting, when that event completes, the process transitions from waiting to ready state, and then it can go back again to running state. So this was a brief recall of the process state transition diagram. So here, only two things we have to change. All of it will remain the same. The names, first of all, we have to change. In the question, they have said that the processes should be in the created state and the block state. Rest of the states, the name are same. Created is the same as the new state, and the blocked is the same as the waiting state. So let me rename the states. So we have renamed the states, and our first condition is fulfilled. So now let us look at the second condition. The second condition in the question is that only non-preemptive scheduling is used by the operating system. So if you see the questions that are related to process state diagram, then this non-preemptive or preemptive, this point has been asked several times in the GATE exam. So having a good idea of how the state transition diagram looks for a preemptive scheduling policy versus a non-preemptive scheduling policy is very important. This concept has been asked multiple times. So as we have already discussed in the other GATE questions related to process state diagram, what is a non-preemptive scheduling policy? So let's first discuss the preemptive scheduling policy. So basically, whenever the operating system is allowed to forcefully take away the control of the CPU from a running process, then that particular scheduling policy or that OS is said to be preemptive in nature. So preemption is basically the event where you take away the control of the operating CPU from the running process. Okay, so the operating system takes away the control forcefully from the running process. Okay, so when that happens, the running process goes from the running state to the ready state. So this transition is basically a depiction that the process was preempted. So in a non-preemptive scheduling policy, this transition will not be there. So let's talk about the non-preemptive scheduling policy. So whenever an operating system follows such a policy, then in this case, the control of the CPU cannot be forcefully taken away from the running process. That is, this transition is not allowed. And in such an operating system, the control of the CPU is voluntarily given up by the running process. So let's say the running process terminates, right? It finishes its execution, then it can give up the control of the CPU, or it can issue a particular operation for which it has to wait, or for any reason it has to wait. Let's say it has requested for a resource, or it has requested for an IO operation, and it has to go to the waiting state. Only in these two conditions, that is when the process goes from running to terminated or running to blocked, then it gives up the control of the CPU on its own. Here, the operating system is not snatching away the control of the CPU from the running process, right? So in a non-preemptive scheduling policy, the control of the CPU will be given up by the running process on its own. So this is the major difference between a preemptive and a non-preemptive scheduling policy. And whenever you see such a question which asks about the transition diagram of a preemptive or let's say non-preemptive scheduling policy, then you have to focus on this transition. If it has been asked to keep preemptive scheduling policy, then this transition should be there. And if it has been asked that the operating system is non-preemptive in nature, then this transition has to be absent. So what we have to do is that in this question, we have to remove this transition. And now the updated process transition diagram looks something like this. So both of the conditions have been fulfilled, right? Basically, we have all the 5 states, and this transition, which was basically for from running to ready state, where the process is descheduled or the control of the CPU is taken away from the running process, this transition has been removed. So guys, this is the final diagram, and this is how it looks like. So this is the answer to this question. It's a fairly simple question. You just have to understand what are the different states in the process transition diagram, and how are the different transitions, what is the nature of or what is the significance of the different transitions in such a diagram. So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.